We're doing Unit 6, Trigonometry Part 2. Our question is to graph each pair below in radians on a separate Cartesian plane. F of x equals sine x and g of x equals cosecant x. F of x equals cos x and g of x equals secant x. F of x equals tan x and g of x equals cotan x. Now we know that sine f of x equals 1 when it's sine of pi over 2. And we know it equals negative 1 when it's 3 pi over 2. And the roots of the equation is at pi and 2 pi. So let's graph that. There's our sine wave. Now to get cosecant x, we know that cosecant x equals 1 over sine of x, which means if sine of x equals 0, then cosecant x equals 1 over 0, which is inadmissible because you can't divide by 0. Therefore, there's an asymptote. So to graph, we're going to put the asymptotes on the graph as dotted lines, and whenever sine of x equals 1, that means cosecant x equals 1 as well, because it's 1 over 1. Therefore, that's what it looks like. So the asymptotes are at where sine of x equals 0, which is at pi and 2 pi. Next is cos x. For the next graph, cosecant x, we know that cos at 0 equals 1, cos at pi over 2 equals 0, cos at pi equals negative 1, cos at 3 pi over 2 equals 0, cos at 2 pi equals 1. So let's graph that. So that's how it looks. And we know that secant x equals 1 over cos x. Therefore, whenever cos of x equals 0, that means that there's an asymptote in the secant graph. And whenever cos x equals 1 or negative 1, secant x equals 1 or negative 1. Let's graph that. So at wherever cos of x equals 0, so at pi over 2 and 3 pi over 2, there's an asymptote. And whenever it equals 1, cos x equals 1, that means secant x equals 1. And whenever cos x equals negative 1, that means secant x equals negative 1. There we go. Next. The tan function is more tricky because it has asymptotes, because the trigonometric ratio for tan is sine over cos, which means whenever cos is 0, tan has an asymptote. So when tan is at 0, it equals 0 because sine of 0 equals 0. You get signs on the top. When it's f of x equals tan pi over 2, there's an asymptote. Because cos at pi over 2 it's equals 0. When it's f at x equals tan of pi, it equals 0 because sine is 0. And at f at x equals tan of 3 pi over 2, it is inadmissible. Because cos is 0. And at f at x equals tan 2 pi, it is 0 because sine is 0. So let's graph that. Okay, 0, asymptote, 0, asymptote, 0. It looks something like this. Now, for the cotangent, we know that cotangent equals 1 over tan. Which means whenever tan equals 0, that means there's in cotangent, it is inadmissible. And it has an asymptote. So, therefore, on this graph, there'll be an asymptote right here, an asymptote right here, an asymptote right here. And we also know that cotangent equals cos of x, cos x over sine x. So therefore, when cos is 0, cotangent is 0, which is at 3 pi over 2 and 2 pi over 2. Which means that tan's asymptotes are cotangent's roots, and cotangent's roots are tan's asymptotes. So let's graph that. So right here, it's tan of x, and tan x. Yeah, okay. And that's cotan x and cotan x. There we go.